Hi everyone. Today we're going to talk about molecular ratios and formulas using something called empirical formulas. All right. The empirical formula it shows the ratio of elements in a compound. Okay, the ratio. The molecular formula shows the actual number of atoms present in a compound. Now, the simplest way to explain this is to refer back to math class. In math class, if you have an answer of 4/8, you're not going to turn that in. You're going to reduce it to 1/2. Well, both of these have the ratios. Your actual answer will be your 4/8, but your empirical, your reduced form would be your 1/2. All right. So to put it into a chemistry example, butene has a molecular formula of C4H8. Now we want to reduce that. Well, to reduce that, we're going to look at the ratio of carbons to hydrogen. They're both divisible by 4. So that means the empirical formula is CH2, just by simply reducing those and finding that common factor. Okay, so CH2 would be the empirical and C4H8 would be the molecular. That's because there is a 1:2 ratio of carbon to hydrogen. Okay, so essentially sometimes we're just finding that ratio or finding that common factor. Okay, so let's do a couple of examples of how to calculate empirical formula. All right, we're going to use butene again as an example. Butene has a molar mass of 56 grams per mole. Now you get, and it's approximate, but you get this from the periodic table. You know, you've got C4H8, and this comes because there are carbon weighs approximately 12 grams on the periodic table, and I've got 4 of them. And I'm going to add that to my hydrogen, which weighs approximately 1 gram, and I've got 8 of those to give me 56 grams. Okay, now I can look at my molar mass of CH2 of the empirical formula. Okay, that carbon again has 12 grams approximately. I'm going to add that to my hydrogen, which is 1 gram, and I got 2 of those, so that gives me 14 grams. Well, look at this. I can figure out, I have a ratio here. Okay, I can use a very simple equation of 14 grams per mole times some factor N equals 56 grams per mole. Okay, so if I rearrange my equation, that means N is equal to 4. Okay, or I can use, looking at my formulas, I can say CH2 times some factor N equals C4H8. Okay, again, looking at that factor, that means I can say that N is equal to 4. Okay, N is simply the multiple Okay, so all we're doing is looking for this factor. All right. Now, what if you're not given a straightforward formula? What if you're given percentages? Let's see. What is the empirical formula of a compound that contains 25.53% magnesium and 74.47% of chlorine? Well, that's a strange question. Well, we need to make kind of a checklist here. We're gonna assume a couple of things. First of all, look at 74 and 25. These two numbers are going to equal 100. So first thing, assume you have a 100 gram sample. Then, second, convert percent to grams. Now in this case, it's equal, so I have 74.47% chlorine is going to be equal to 74.47 grams of chlorine, and likewise for magnesium. Percent magnesium is equal to 25.53 grams of magnesium. Okay. Step 3, find atomic mass. Okay, magnesium on the periodic table weighs 24.305 grams. Chlorine on the periodic table weighs 35.453 grams. Okay, next thing, this is where we're gonna make our own ratios. Calculate each ratio. So I'm going to take magnesium. Well, you're going to do that by taking your percent in grams, and you're going to divide that by your atomic mass. Okay, so for magnesium, I'm going to take my percent in grams, so 25.53 grams, and I'm going to divide that by my atomic mass, which is 24.305 grams. All right, and the same thing for chlorine. Whoops. Chlorine, my percent in grams was 74.47 grams. I'm going to divide that by my atomic mass, which is 35.453 grams. Okay, I'm going to do these calculations. Magnesium, I get 1.05, and chlorine, I get 2.10. But even still, that's a strange number. Okay, well, the fifth thing you're going to do is divide each element by the smaller ratio. So magnesium, I have 1.05, chlorine, I have 2.10. Well, clearly 1.05 is smaller, so I'm going to divide both by 1.05. Okay, so for magnesium, that's going to give me a 1, and chlorine, that's going to give me a 2. Okay, now step 6, convert to empirical, which is Mg1Cl2. And that is my answer. That is 74% chlorine and 25% magnesium, MgCl2. All right, now sometimes these ratios here don't come out in perfect whole numbers. So let me do one more example here. A sample weighs 43.85 grams and contains only carbon and hydrogen. The amount of carbon is 38.94 grams and hydrogen is 4.91 grams. We're going to find the empirical, okay? So, step one, assume you're dealing with a 100-gram sample, okay? Now, what if it doesn't equal 100 grams? That's okay. You can just use what you're given. So, I've got my carbon, 38.94 grams. And I've got my hydrogen, 4.91 grams, okay? Step two, you convert. You didn't have percentages, so we didn't have to convert. Step three, find your atomic mass. So carbon on the periodic table is 12.01 grams. Hydrogen on the periodic table is 1.008 grams. Okay, and we're going to step four. We're going to find those ratios. So for carbon, I get 3.24, and for hydrogen, I get 4.87. Again, some very strange numbers. Okay. Step five is you're going to divide by the smaller ratio. So clearly 3.24 is smaller. All right. So I end up with carbon is equal to 1 and hydrogen is equal to 1.5. So my empirical formula is C1H1.5. That's strange, because you can't have a half of an atom. So here's what you got to do. If you find that you have a decimal place, then you can simply multiply through by a common factor. So that would give me, I'm going to distribute this 2 to both. All right, so I get C2H3, and that's going to be my final answer. Okay. You can end up with 0.5s in your ratio, so you'll multiply by 2. You can end up with 0.33s, so you just multiply by 3. Same with 0.66, just multiply by 3. If you end up with a really, really odd number like 0.47 or 0.41372, you probably did something wrong. So these are the only decimals that you're probably going to end up with. Okay, so if you end up with any of those, then you can just multiply by those common factors to give you whole numbers. All right, but that's mainly what we're covering, is just being able to look at your percentages or look at your grams that you start with and figure out what the ratio is. What is that empirical formula? Okay, so that's about it, and that's all for Unit 5. Next unit, we're going to talk about nomenclature and how to get these formulas, how to get these numbers and where they come from, how to bond them, how to name them even. Okay. Until then, work together, help each other, and make the world a better place. See ya.